I'm Rajesh Uppal, Director IDST. We bring sharp insights and foresight on defense, security, and emerging tech. Let's dive in.
Imagine a world where computers solve problems that today's most powerful machines can't even touch, like designing new drugs in hours, optimizing global energy grids, or cracking the toughest cybersecurity codes. Welcome to the quantum computing revolution, where the future of computing is not just theoretical anymore, it's happening right now. Quantum computing started as a bold idea, rooted in the weird world of quantum physics, where particles can exist in multiple states at once and entangle across vast distances. But today, this field is no longer just the playground of physicists tinkering in labs. It's rapidly transforming into a vibrant ecosystem of innovation, technological breakthroughs, and real-world applications. So why all the excitement? Because quantum computers don't just process bits as zeros and ones like classical computers. They use quantum bits, or qubits, which can be both 0 and 1 at the same time thanks to a property called superposition. This allows quantum computers to perform many calculations simultaneously, crunching complex data in ways classical computers never could. And what about entanglement? It's like a secret quantum handshake between qubits, allowing them to share information instantly, even over long distances. Combined, superposition and entanglement let quantum machines solve problems in seconds that would take classical computers millennia. This shift isn't just technological wizardry. Governments and industry giants are pouring billions into quantum technologies because they see the massive potential. In fact, last year alone, global investments in quantum computing topped $40 billion, and China leads with over $25 billion invested since the 1980s. Countries like Japan, the UK, Germany, France, and the US aren't just sitting back. They're building national quantum strategies, forming research hubs, and setting ambitious goals, like Japan's push to build quantum-ready engineers and the UK's $2.5 billion strategy to create a quantum-powered economy by 2035. And here's a powerful indicator of real progress: patents. In the past decade, quantum computing patent filings skyrocketed by 25% every year. That's not just about more ideas, it's about maturing technology. We're seeing breakthroughs in qubits, quantum gates, error correction systems, and quantum algorithms, all signs of a fast-evolving industry. Think about companies like IBM launching advanced quantum systems and NVIDIA setting up dedicated quantum research centers to combine quantum and classical computing power. Meanwhile, startups like IonQ and Quantinuum are shifting from lab experiments to real-world engineering and commercial products. And the pace doesn't slow. Just recently, physicists unveiled an 8-qubit topological quantum processor, a huge step forward that promises more stability and scalability. Plus, the number of physical qubits is doubling every year or two since 2018. That's exponential growth, the very essence of quantum potential. Of course, building these machines isn't easy. Qubits are fragile, prone to noise and errors. That's why technologies like quantum error correction and new performance metrics such as quantum volume and reliable quantum operations per second, or RQOPs, are crucial. They help measure how good a quantum computer really is, beyond just the number of qubits. But the real power lies in where quantum computing is headed. Imagine future GPS systems pinpointing locations down to millimeters, autonomous spacecraft navigating the solar system with incredible precision, drug companies designing custom molecules in record time. banks using quantum-powered algorithms to prevent fraud, and the race for quantum-resistant cybersecurity becoming a top priority as quantum computers threaten to break today's encryption. The economic potential is staggering. Experts predict quantum technologies could generate up to $850 billion by 2040, while creating hundreds of thousands of new high-tech jobs along the way. The market is already valued at over $1 billion and expected to skyrocket towards $28 billion by 2033. Yet, hurdles remain. Building stable, large-scale quantum machines, reducing error rates, and integrating quantum hardware with existing tech infrastructure are still active challenges. But the collaborative effort of governments, industries, and academia is driving solutions faster than ever. In short, quantum computing isn't just advancing, it's co-evolving as a system of interconnected innovations. The ecosystem is maturing before our eyes, transforming from isolated research experiments into commercially viable technologies that will revolutionize industries and redefine the very fabric of computing. The quantum revolution is no longer on the horizon. It's here, building faster processors, enabling smarter solutions, and rewriting the rules of what's possible. Timing really is everything in this quantum era. Thanks for watching. Subscribe, follow, or visit idsth.com for more cutting-edge defense and tech insights. See you in the next one.